So now we're looking at exercise 3F, page 86, and if you just read the question there, we're looking at a radioactive substance that decays at an exponential rate. So the weight decays at the rate of 20 e to the minus kt grams, and t is in hours. And so we must begin by finding k with the information that the weight is 10 grams after 50 hours. So we're putting in the 10 grams for the weight. And we don't know k, but we know that t was 50. So just dividing both sides by 20 so that we can get e to the minus k times 50. So it's standard to put the number in front of the k, minus 50k, equals 10 divided by 20 is a half. Now as soon as we see the exponent on its own, if we take the natural log of both sides, now often this isn't written, so once you get really confident you may not write ln of both sides, you might just immediately write minus 50k, and you might also notice that ln 1 divided by 2 can be written ln 1 take ln 2, and we know that the natural log function passes through 1, 0. So when x equals 1, the natural log equals 0. So that's just going to be minus ln 2. Divide both sides by a negative 50. We're going to get ln 2 divided by 50 for our value of k. So I've just calculated k to be approximately 0.0139 because when I reread the question it's not asking for exact values. So part B, we've asked to find out the weight in 3 different times. So I'm immediately thinking I can put this into my calculator. So I've written the weights at 0 time, at 24 hours, and the last one was after a week. So there are 7 days in a week, 7 times 24. I can work that out a bit later on my calculator. So if we turn on our calculator to the graph menu and we enter the function, so instead of w we've got y, it's going to be 20 e I've lost the e function. There it is. To the power, and I'm just going to put brackets to be extra careful. Negative 0.0139, negative 0.0139, and instead of the variable t we'll use x. Now if we draw it, we may not get a very good function. So if we just think back, we know that when the weight was 10 grams, so that's the y value of 10, the time was 50 hours, and we also know that we're going to work out a time of 7 times 24. So I should have calculated that. So I just use Shift Zoom Auto, and even though that's not a very satisfactory appearance of the function because we expect it to be curved and it looks linear, let's just put in the GSolve calculation for, now remember we've got the weight is like the y coordinate, so if we go Shift GSolve, because you can only use this when you've drawn a picture or a graph, I want to work out the x value, the time, when I know the y. So I'm going to do a calculation of the x, F2 is, and I'm going to put in, no, I've done it the other way. we want to find out the weight, we want to find out the y value when the time is 0. So let's just exit. Have to draw it again. Shift G solve. So we know the time, so we want to calculate y. We know that the time is 0 and y equals 20. And with a quick check, that's correct because e to the power 0 is 1, so the answer is going to be 20. So we'll do it again, Shift G solve, and we want to do the calculation of the x value, but this time we know that the y, no, I've done it backwards again. Shift G solve. We want to calculate the y value knowing that the x value is 24 hours. Doesn't like it. So that means my view window isn't large enough. Shift view window. So exit. Shift view window. Well, we want it from 0. Our maximum x value is actually going to be about 170. So let's go up higher. And the y value should be getting smaller because it's 20 over e, so it should be getting smaller. So it doesn't have to go to a particularly large number. The minimum value, let's have 0. The maximum value, let's have 30, just see how that goes. Alright, now let's try again. So some of these problems are good to notice. Shift G solve. We want to do the y calculation knowing that the x value is 24. And now it works. So it's 14.3. And so in a similar manner we calculate that after 168 hours that the weight will be 1.935 grams. So I've just realised I haven't written the units on my answer, so I just go back, put grams on them all. Part C asks how long will it take for the weight to reduce to 1 gram. Now we've already got that it takes 168 hours to get to 1.9 grams. So we're expecting a number bigger than 170. So if we divide both sides by 20, we're going to get e to the minus 0.0139t equals 1/20. If we take the natural log of both sides, we'll get minus 0.0139t equals the natural log of 1/20. So rearranging for the time and entering it in your calculator, I get 215 hours or 0.5, and that is larger than the 168 hours to get the 1.9 weight, so that's looking like a good answer.